Baseline drift in high-performance liquid chromatography refers to a gradual, systematic change in the detector signal over time, even in the absence of analyte elution. Unlike baseline noise, which is random and short-term, drift occurs slowly and predictably across a chromatographic run and can significantly compromise quantitative accuracy. One of the most common causes of baseline drift is mobile phase composition changes. In gradient elution, differences in UV absorbance, refractive index, or viscosity between solvents naturally alter the detector response. If solvents are not properly matched, degassed, or equilibrated, this effect becomes more pronounced. Temperature fluctuations are another major contributor. Changes in column oven temperature, laboratory ambient temperature, or detector cell temperature can affect solvent density, analyte response, and detector electronics, leading to gradual signal shifts. Baseline drift can also originate from the detector itself. UV lamps age over time, photodiodes slowly lose sensitivity, and detector electronics may warm up during operation. These effects often appear as a steady upward or downward baseline trend, particularly during long sequences. Finally, system contamination and equilibration issues play an important role. Slowly eluting impurities, column bleed, or insufficient column re-equilibration between runs can all manifest as baseline drift. In practice, minimizing baseline drift requires stable temperature control, well-prepared and degassed mobile phases, adequate column equilibration, and routine detector maintenance. Recognizing the underlying cause is essential, because baseline drift is not just a cosmetic issue. It directly affects integration, sensitivity, and long-term data reliability.